continuity is in terms of what is called the intermediate value theorem. It says if we have a function that's continuous on a closed interval from a to b, and f of a is not the same as f of b, then there's going to exist a number that would make another y value be between f of a and f of b. I know that sounds all crazy, but what that really is stating is if I know I've got a continuous function, and here's a and here's b, and it doesn't matter which one's on top. Let's call this will be this point, so this is f of a, and here's this point, and that would be f of b. What the intermediate value theorem says is that if f is truly continuous, then to get from point A to point B, I've got to pass through every other y value on this graph. I challenge you to try to connect the dots without going through every y value. It's impossible. To connect them, even if I went up, I have to go back down and come back to B. So I am still going to pass through every point from f of A to f of B. Even if I did a straight line, I'm still going to pass from every point from f of A to f of B. So let's see why this is helpful. So I'm going to do, the main reason this is helpful is that if we know we have a continuous function, this can help us narrow down where we have a 0. So the way we could use this is say I'll just use the example here. So given f of x equals 4x cubed minus 6x squared plus 3x minus 2, is there a 0 between 1 and 2? In other words, the x values 1 and 2. Well, the first thing I want to think about is this going to be continuous? Well, this is a polynomial, so the first thing I want to state is f of x is continuous for always, but it's definitely continuous on the interval from 1 to 2. Definitely, okay? Now I need to double check that f of a does not equal f of b. So I'm going to check f of 1 and f of 2. So I'm going to do f of 1 and f of 2. So I'm going to plug in 1 for all my x's. It's going to give me 4 times 1, blah, 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 minus 6 times 1, plus 3 times 1, minus 2. That's going to give me negative 2. That's a negative 1. And then I need to find f of 2. That's going to be 4 times 8 is 32, minus 6 times 4 is 24, plus 3 times 2 is 6, minus 2. It's an 8, 14, 12. So I have these two y values. I have a y value of negative 1 and I have a y value of 12. The intermediate value theorem says to get from negative 1 to 12, I've got to pass through every y value in between. So does that prove that there's a 0 between them? Well, yes, it does. There must exist there exists a number C on the interval from 1 to 2 where, oh, that's not how you spell where f of C equals 0. I proved that it's between those 2 points. There must exist one. What about if I had, let's see, f of x equals x minus 3 over x plus 2? Is there a value on -1 to 3 where f of x equals 2/3? Well, first off, is f of x continuous? It's not continuous everywhere, but is it continuous on this interval? It is. So I could state f of x is only discontinuous at x equals -2. It's fine everywhere else. So it's fine on -1 to 3. The next thing I want to check is I want to find f of -1. And then I'm also going to find f of 3. So f of -1, I'm going to plug -1 in for my x's. Okay, so we got -4 for our first y value. Then f of 3 so we've got the y values of -4 and 0. Well, do I need to pass through 2/3 to get from -4 to 0? No. 2/3 is not between -4 and 0. Sometimes we abbreviate the intermediate value theorem as IVT because I'm a lazy mathematician. Does not apply. So remember, our y value had to be between those for this to work.